Hello everyone. So today we will see how much GMBYID value is for different inversion regions like weak, moderate and strong inversion. How much GMBYID value for your technology node. Okay, so for that we will plot GM over ID versus V over drive of that MOSFET. Okay, so I hope you know how to plot GMBYID plots. Okay, so if you don't know, please go watch my videos so you will be able to plot. So in this video, I have already plotted that GM over ID versus V over drive of for PMOS. Okay, so I'm showing that graph. So this one is y-axis is GM over ID and x-axis is V over drive. Okay, minus of VGT. So we know that near VTH, we will be in like a weak inversion. If our VGS will be less than equal to VTH, then we will be in weak inversion. So when VGS equal to VTH, our V over drive will be 0 millivolt, okay, or 0 volt. So I will put a marker, I will press V, and here I'll write 0, okay, enter. So here my VGS is equal to VTH and my V over drive is 0. And the corresponding GM/ID value is 29. Okay, so below VTH, VGS less than VTH, my V over drive will be less than 0, and my GM over ID will be greater than, suppose I am saying it's 30. Okay, so above 30, this region is weak inversion region. So V over drive less than 0 millivolt, our GM over ID will be greater than 30, and it will be in weak inversion region. So it's like simple. And so how we will decide moderate and strong inversion region? For that, we know that there is one equation, ID equal to I naught e to the power VGS by zeta Vt on minus e to the power minus of VDS by Vt. Okay, so when VDS will be greater than equal to like 4 Vt, okay, so we say that our MOSFET is in like is strong inversion, or it will follow square law. So because Vt is like a thermal voltage, and at that voltage our thermal effect will be very high. So at least four times that thermal voltage, 100 millivolt to more than 100 millivolt, our thermal effect will be very less in our MOSFET. So there will be no non-linearity, that much non-linearity. So we say that Vt is greater than 4 Vt, that will follow square law. So now we will use this condition to check our inversion regions. So here I will put a marker at 100 millivolt, 4 times of VTH value. I like thermal voltage value VT. Okay, that's not VTH, that's VT. So I will put a marker here, and I will give here 100 millivolt. So here we can see that GM/ID value is 20 or 19. Okay, so and if we are increasing our V over drive, like V over drive increases, so our there will be more electrons below that oxide, and there will be more inversion, so that will be in more highly strong inversion. Okay, so for a safe region, I am giving some more margin, so I am going to suppose 130 millivolt. Okay, so there is like a GM/ID value of 16. So here I will say that if you have a drive less than 0 millivolt, I will be in weak inversion region, and 130, 140 below, between 0 to 130 millivolt of overdrive, I am in moderate inversion. After 4 VT, or for some safe margin, I am saying that 130 millivolt. After that, I will be in this region is strong inversion region. Okay, so higher V overdrive will be higher inversion layer, and that will be strong inversion. So now, so you can what will be the GMBYID values? Suppose I am saying 16. Okay, so here its value is 30, and here is its value is 16, corresponding to 130 millivolt. Now, okay, so I plotted the plot GMBYID. So I got this one. So I took W equal to 1 micrometer. So when you doing by your own, so you can see that if you are increasing this to 5 micrometer, I mean you are changing if this, then this graph don't change that much. Okay, so you can check, and I have taken L equal to 10 micrometer, 5 micrometer, and 1 micrometer. Okay, so this one is for 10 micrometer, and this one is for 1 micrometer. And x axis is V over drive, that is minus of VGT, and here GM over ID. Okay, so for V over drive of 0 millivolt, okay, so this is 0 millivolt, and VGS will be less than equal to VTS. So this will be in weak in inversion, and I got here value of GM over ID of 30. Okay, and I took 4 times thermal voltage, so I got like 100 millivolt, but for safe margin I took 130. Okay, so here I am marking 130 millivolt V over drive. So what I got here, I got 16 GM over ID. Okay, so for in this region, in this region I will be in weak inversion region, and my GMBYID will be more than 30. In this inversion, this region, I will be in moderate inversion, and my GMBYID will be between 16 to 13. Okay, 30. And in this region, I will be in strong inversion region, and my GMBYID will be less than 16. Okay, we can summarize like this also. Suppose this one is GMBYID. So here it's 16, here it's 30. Okay, and that is V over drive. Okay, this one is 132 millivolt, and this one is 0 millivolt. So GM/ID is inversely proportional to V over drive. We know that GM/ID will be 2 divided by V over drive. Okay, now so this will be in strong, this will be moderate, and this will be weak inversion. Okay, so V over drive increasing this side, and GMYID increasing this side. Okay, so you can correlate both things. Okay, now let's summarize. So again, let's go to the that. So here VGS is VTH. So V over drive is 0, and VGS less than VTH. V over drive will be negative, and we will be in weak inversion region, and we are getting greater than 30 of GM/ID. In this region, we are in moderate inversion, and V over drive will be 0 to 120 millivolt. Okay, 130 millivolt, and after that, and in this region, GM/ID is between 16 to 30. Okay, and after this, V over drive is greater than 130 millivolt, and our GM over ID is decreasing below 16. So below 16, we are in strong inversion region. So I hope I was able to explain. Okay, so if you have any doubt, then please let me know. I'll try to explain. Okay, thank you.